All right, let's talk about something that sounds like it's straight out of science fiction. Antimatter as topological mirror knots. And I gotta tell you, this isn't just some new theory about particles. Nope, this is a whole new way of looking at, well, everything. A radical reimagining of the very fabric of reality itself.
So let's just start with a question that's gonna flip everything you think you know on its head. Ready? What if particles aren't, well, things? You know, we always picture them as these tiny little billiard balls, this fundamental stuff. But what if that's totally wrong? What if a particle is just a behavior, something that space-time itself is doing, like a pattern or a dance, or maybe a really stubborn knot in the fabric of reality? Okay, so to even begin to wrap our heads around that, we have to throw out one of our most basic ideas, the idea of empty space. We're talking about a completely new fabric of reality. So, let's break this down. The old way of thinking, the one we all kind of grew up with, is on the left. You've got space as this big, empty stage, just a boring, passive backdrop. And then you have particles, the actors, running around on the stage. Simple enough, right? But now look at the right. This new idea completely flips that. Here, the stage is the actor. Space isn't an empty void at all. It's a dynamic, constantly vibrating thing, a self-oscillating phase field. It's alive. It's active.
All right, so if space is this vibrant, oscillating field, then that begs a pretty big question, right? Where does all the stuff come from? You know, the solid, tangible particles that make up you and me. Well, this is where it gets really cool. The answer is, they're not separate objects. They are literally knots in space-time.
Yeah, you heard that right. Let's just pause on this for a second, because this is the absolute heart of the whole idea. Matter is not something inside space. Matter is what space is doing. It's not a separate thing placed inside a box. The box itself gets twisted up. It gets tangled into a stable, self-locked pattern. And that pattern, that behavior of space, is what we see and touch and call a particle.
And there's a technical name for this kind of knot. It's called a topological defect. It sounds complicated, but the idea is actually pretty simple. Think about a really tight knot in a shoelace. You can't just pull on the ends and have it smooth out, right? You have to actually work to untie it. That's a topological defect. It's a piece of trapped geometry. It's a configuration of space that's locked in place, kind of like a permanent, stable scar in the fabric of reality.
And this model goes even deeper. It doesn't just explain what a particle is, it explains its properties, like charge. And get this, charge isn't some weird magical property that's just stuck onto a particle. Nope, it's just geometry. It's literally just the direction of the twist in that knot of space-time. Is it twisted clockwise or is it twisted counterclockwise? That's it. That one simple difference is what we call positive or negative charge.
Okay, so this is all building up to something really elegant. If matter is a knot with a certain twist, then that gives us an amazingly simple way to think about its mysterious twin, antimatter. We're calling it the mirror knot.
So let's just stop and think about this for a sec. We've just said that a particle with a certain charge is just a knot in space-time, twisted one way, say counterclockwise. So following that logic, what do you think its antimatter partner with the opposite charge could possibly be?
And boom, there it is. The answer is just so simple, it's beautiful. Antimatter is the mirror image. It's the exact same knot, but with the opposite twist. So if you have a matter knot with a clockwise twist that gives it a positive charge, then its antimatter counterpart is an identical knot, but with a counterclockwise twist, giving it a negative charge. They're perfect mirrors. The only difference is their geometric handedness. It's that simple.
Now this perfect mirror image thing, it leads us straight to one of the most powerful and frankly violent events we know of in the universe, annihilation. But here's the twist. In this way of looking at things, it's not destruction at all. It's something else entirely. It's the great unwinding.
So how does this unwinding actually work? Let's just walk through it. Step 1. A knot comes face to face with its perfect mirror image. Step 2. Their opposite geometries, their opposite twists, start to interact. And this is the crucial part. Step 3. Because they're perfect opposites, they cancel each other out. It's like a +1 meeting a -1. They just unwind. The knots disappear. And finally, step 4, all the energy that was trapped, that was holding those knots in their twisted shape, it's released back into the field as pure, untangled vibrations. We see that release as a burst of radiation.
So the big takeaway here is this. Nothing is actually being destroyed. That's the wrong word. Annihilation is just space-time smoothing itself out. It's two complex, tangled-up parts of space-time meeting, canceling out, and just relaxing back into a simpler, untangled state. The energy was never created or destroyed, it was just locked up in the geometry, and now it's free.
So let's just do a quick recap of the massive ideas we've just covered. We threw out empty space and replaced it with an oscillating field. We stopped thinking of particles as things and started seeing them as topological knots. That made antimatter a simple mirror knot. And finally, destruction became unwinding. I mean, that is a complete and total rewrite of our picture of reality.
And thinking this way is it's incredibly powerful. It leaves you with this one final massive question to chew on. If matter and antimatter are nothing more than geometric patterns, just persistent shapes in the fabric of reality, what else is out there? The big mysteries like gravity or dark matter. Could they also just be shapes, topologies in space-time that we haven't figured out how to recognize yet?